Hey, this is the screencast for sound waves, and yes, this is a periodic wave since we can see a different, like same patterns over and over again. And how many waves do you guys think has?
Two, three, four, five, six. About seven.
Seven,
About
seven
waves.
per,
Yeah, seven.
seven per waves, and this is, for example, lunch passes by snail paces. Really, how long the probe will collect the data to something in your everyday experience?
It's very fast.
It's very yes, it's very
Wavelengths
fast.
do it in less than 0.01 of a second.
Yes, so we can basically hear anything from. We can basically hear anything, especially towards the hallways, where everything just goes back and forth, back and forth. What is the period of these waves?
Well, it's just the little space that is between the two high points. Yeah.
Yeah.
Yeah, which is 0.05.
0.005.
0.005 seconds.
The distance between the two.
Yeah, the distance between these two, which basically all of them are the same. The frequency of these waves.
Jensen.
Is the
Yeah, hey guys.
bottom.
So the frequency. What's the frequency of these waves? The frequency. So the frequency should be like around it's top to bottom. Yeah, it's like basically top to bottom. So if we actually just highlight this here, and so the frequency is about, I guess, about 9,000.
I didn't do anything to you.
And
Tell Dan.
so how we determine the frequency because by subtracting the time here and the time here and the endpoint here, and because that one makes the most sense. If we're wrong, oh well. The wavelength. I don't think we've learned much about the wavelength, so I can't explain to you about that. However, what is the amplitude?
Isn't that how much it takes for one thing to go?
Yes, that's about like one thing, or basically one oscillation.
So that would be when we did 0.05, the same?
So it will be each of these like yeah.
So
Yeah, like
okay.
just like a small part over here,
Yeah.
and small and another small. So from oscillations from here to here, that is how much the amplitude is, which is about like
0.05.
yeah point like 0.01.
0.01.
0.01 or like 0.001. It's like a 1 of a hundredths.
That's
Um,
cool.
what would be the different about the graph if you were 10 times as long?
They would be the same.
Yeah, they
Because
would.
just keep going.
Correct. They would be the same. And how would your answers to questions from A to G change? They would still also be the same since they're also just repeating itself over and over again.
Yeah.
Now I should say aw.
Hold on. Okay, we're changing now.
We're changing awes.
So this is Jake's Oz. And it's not. And as you can see, it's actually just showing the same patterns over and over again. And we can see that the
It's just a little more spread out.
It's a lot more spread out than mine's. The amplitude here is 0.04, 0.004, so 0.004 minus about
You have one too many fours.
0.004. It's 0.004.
You have 3 zeros.
Oh, 3 zeros. All right. 0.004 minus 0.0071, which is about 3.1 of 31 of 10 thousandths. 31 over 10 thousandths. So that is the, what was it again? That was the wave. No, I think it's the waves. No, that is the period.
Yeah.
Yeah.
Frequency is from here, 0.005.
It's like 2 point. It's about the same as the other one.
Yeah, it's about 0.3. It's not. It has a really small comparison because it's so fast that the numbers can't catch up. The amplitude of the waves is basically from here to here, which is about not even a second.
0.01.
A tenth of a second. It's not even tenth of a second.
Wow.
So it's like a hundredth of a second. And now we're gonna do the tuning fork. And how do we collect data by tuning fork and constructing it with a soft object? Once you get the graph, you show it to me on the screen and follow the app. So, Jocelyn?
Okay.
What can you show me about this graph? That's comparable to what we had graphed so far.
Well, the frequency, well, it seems like there is no frequency, also altitude, and because the fork is about 277.1, means that you don't make too much noise, right?
Yes,
Yeah,
yes.
it's not like the voice, yeah.
It's not like a 431 fork. So the amplitude and the waves here are actually very small, as well as the periods. Oops, that's not it. If you use the same card to collect data for a sound that's not loud, what changes do you expect from sound?
It would be even smaller.
Exactly, yeah. The waves would get smaller. As if there's a small amount of waves or sound, that means the waves get smaller as the ones in the fed data. And that's pretty much it. So Jensen, Jake, and Jocelyn, 3 J's. Bye.